Hello and welcome to the video on derivatives. If you haven't watched the video about limits and continuity yet, please make sure to watch that before this, especially if you know nothing about limits and continuity. The first thing we're going to talk about in today's video is what's the point of a derivative? Why do we want to use derivatives? So we use derivatives for two reasons. First of all, to find the slope of the tangent to a curve. What does that mean? Well, if you're looking at a curve like this, let's just say you've got this kind of nice looking curve right here. How are you going to find the slope to this point right here? What about at this point right here? Or at this point right here? They're all going to be completely different from each other. So the way to find the slope for it is to find the slope of the tangent to that curve at a specific point. So by finding the derivative, we can find the slope of this line right here at this point right here, which gives us the slope of this point right here. So that's reason number one that you would use derivatives. Another reason, or the second reason, there's only two reasons, is to find the sense of variation of that curve. If you have a function, it can sometimes be pretty difficult to figure out when it's increasing, when it's decreasing, if it starts decreasing again after that, and then increasing or what. You can use derivatives to find when it increases and when it decreases. So those are the two reasons why you would use derivatives. Now, what is the definition of a derivative? If you know nothing about derivatives, what is a way to find the derivative? This is called definition. Definition of derivative. Okay, the definition of a derivative says that the limit of f of x plus h, let me just make sure that that's right, plus h, yep, f of x plus h minus f of x divided by h, this is the limit as h tends towards 0, is equal to the derivative of that function. Now, if you know anything about math, you know that when we see something like this, okay, let's start with our derivative. Let's say our derivative is x squared plus 4x. F of x plus h, all you have to do is replace the x by x plus h. So in this case, it would be x plus h squared plus 4 into x plus h. All right? And then you just plug it in here and you solve it like a normal limit. And the answer that you get is the derivative of that function. Now, the next thing we're going to talk about are the rules of derivatives. These are really important, and if you don't have them memorized, you're not going to be able to solve derivatives. First things first, the most basic rule of all. If the function f of x is equal to x power n, the derivative of that function, f prime of x, is going to be equal to nx to the power of n minus 1. So this n, whatever number this is going to be moved down and multiplied with this, okay? And then the power is going to have 1 subtracted from it. Let's give an example or two. If the function is x power 4, the derivative, let's take a second and think about this if you want, what it should be. You're going to move the 4 down. It's going to be 4x, and then you're going to subtract 1 from the 4 to get 4x power 3. If it's a negative number, the same rule applies. If you have x power minus 5, the derivative of that, you're going to take the minus 5, you're going to move it down here, so it's going to be minus 5x and then you're going to subtract 1 from this. Minus 5 minus 1 is minus 6. So the derivative of x power minus 5 is minus 5x to the power of minus 6. There's one more case that you can take, and that's if the x has something in front of it. So let's just say f of x is equal to 2x power 3. The same rule applies. The derivative of that, you're just going to take this 3 down, multiply it with this, and then subtract 1 from it. So you're going to have the derivative of 2x power 3 is 6x power 2. Now, moving on to the next rule. So rule number 2. If the function is a constant, the derivative of that constant is going to be 0. Literally any constant that you can think of, the derivative of it is 0. For example, if you've got the function is 5, the derivative of that is going to be 0. It does not matter how big this number is. You can have a number as big as 3, 9, 7, 6, 4, 3, 2, 8, 6, 7, 9, and the derivative of that is, you guessed it, 0. Moving on to our third rule. Our third rule states that if your function is, let's see, okay, let's say our function is u times v. All right, if that is your function, if your function is something that looks like this, okay, u and v being any two like expressions or whatever, okay? Not expressions, I guess, but u and v being any two things, then the derivative of that function is equal to u prime, which is the derivative of u, times v, plus v prime, which is the derivative of v, times u. For example, if you've got the derivative of, let's see, x squared, okay, times y power 3. The derivative of that, okay, so first let's identify u. U is x squared. U prime, we can go back to this, is 2x. So the derivative of x squared is 2x. V is y power 3. So v prime, or the derivative of that, is 3y squared. Okay? So the derivative of x squared times y power 3 is u prime, which is 2x, times v, which is y power 3, so 2xy cubed, plus v prime, which is 3y squared, times u, which is x squared. So that's how you find the derivative of two terms multiplied by each other. Now, how would you find the derivative of, let's see, case number 4. The derivative of f of, okay, we've got function f of x, which is equal to u over v. The derivative of that, f prime of x, is going to be equal to u prime v minus v prime u over v squared. For example, let's say you've got, let's see, I'm trying to think of something. Let's say you've got function 2x power 3 over x power 4. We'll keep it simple, okay? Let's identify u. u is 2x power 3. So the derivative of that, u prime, we're going to take this 3, multiply it by the 2, and subtract 1 from it. We're going to get 6x power 2. V is x power 4. The derivative of that is going to be 4x power 3. So the derivative of 2x power 3 over x power 4 is u prime, which is 6x squared, times v, which is x power 4, minus v prime, which is 4x power 3, times u, which is 2x power 3 as well, divided by v squared. V is x power 4, it's going to be x power 4 squared. And then you can continue this. Obviously, I'm not going to because it's kind of a waste of time for me, but that is how you would find the derivative of that. Now, there's one more important thing to mention. When you've got a long term that looks, let's see, something, wait 1 second. Let's say you've got something that looks like this. F of x, can you see this? There we go. F of x is equal to 2, or you know what, no, is equal to 2x minus 4 power 3. How would you find the derivative of that? So the first thing you need to do is you just take it normally. You assume that this is like just one, collective term. So f prime of x is equal to 3 times 2x minus 4. But there's something important about this. You need to multiply it, or is it multiply? Yeah, you need to multiply it by the derivative of whatever's inside the parentheses here. Oh wait, so this is 3 into 2x minus 4 power 2. Sorry, this is power 2. Multiplied by the derivative of what's inside this. So derivative of 2x minus 4 is just going to be 2. So then you just find the derivative. You just continue solving it normally, and that is the derivative of something that looks like this. That should cover all of the important rules for derivatives. We're going to move on to something called the golden rule. Let's write it all fancy. Golden rule. Add some stars or something around it. The important thing is to never forget this. When you are finding the derivative of something, okay, you figured out what the derivative is, all right? Let's say we're going to take an example. We're going to say f of x is equal to x squared minus 4x, okay? The derivative of that is going to be equal to 2x minus 4. I think we can all agree on that, right? Just put a box around this just so can we remember. Now, remember how we said that one of the purposes of a derivative is to find the sense of variation? Well, when something goes from increasing to decreasing or decreasing to increasing, doesn't it have like sort of a curve? Like it has a point where it switches, right? It doesn't just like magically go up. It's got to have a point where it switches. And to be able to find whether it goes from decreasing to increasing or increasing to decreasing, you need to find that point. Those points are called critical points. The points where they go from increasing to decreasing or decreasing to increasing, those are called critical points. Okay? How do you find these critical points? It's actually quite simple. You set the derivative equal to 0. So you find the derivative of something, and then to find where it goes from increasing to decreasing, you just say f prime of x is equal to 0. And then you just solve it like a normal equation. 2x minus 4 is equal to 0. So 2x is equal to 4. So x is equal to 2. So on the graph, right, when x is equal to 2, it's going to go from either decreasing to increasing or increasing to decreasing. That is how you find where it switches. Now, how do you find the equation to the tangent at a certain point? Let me write those words down because I know that I can't just listen to a word and understand it. Equation of the tangent to the curve at a specific point. We're going to name it x equals a right now. So going back to the beginning of the video, remember how I said that the other reason you would use a derivative is to find the slope of the tangent at a certain point? How do you find the equation of that tangent? You know, equation y equals ax minus b. How do you find that equation? Remember, we said that our point is x equals a, all right? So what we're gonna do, we're gonna take the this is how you find the equation. Y minus f of a, okay, is equal to f prime of a times x minus a. Let's take, okay, we're going back to this function right here. Let me just write it out for you again. So let's say we have f of x is equal to x squared minus 4x, and f prime of x would then be equal to 2x minus 4. At point x equals 2, so when x equals 2, what's the equation of the tangent to that point? Or of the equation of the tangent to the curve at that point? We're going back to this rule right here. Y minus f of a, so in this case a is 2, so f of 2 is equal to f prime of 2 into x minus 2. So now f of 2 we just replace, so y minus, let's see, 2 squared plus 4 times 2. So again, I switched the sign of these because this is negative right here, so these two signs switch, okay, is equal to the derivative, so 2 times 2 minus 4, so whatever that answer is, times x minus 2. So we're going to get y minus 4 plus 8 is equal to 0 times x minus 2. So in this case, I know it came out as 0, but you know, it could be any number. It doesn't have to be 0. So y is equal to minus 4. That is the equation of the tangent to the curve of this function at x equals 2. There you go. That's everything you need to know about derivatives.